everyone, and welcome to day 8 of solving LeetCode problems on Tom Hire by FAANG company. Today we're going to be solving 350 intersection of two arrays 2. So given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. Okay, sounds very straightforward. So example 1, we have nums 1, 2, 2, and 1. And for nums 2, we have 2 and 2. Of course, 2 repeats itself here. And the other 2 repeats itself here, right? So we would return 2 and 2. Right, so this looks very straightforward. And just to be clear, we could obviously make an algorithm that would be that its time complexity would be of O of length of n1 times n2, length of n2, right? Just iterate, check this and all of this, check this and all of this. So one approach here is having two different hash maps, right? One for nums1 and one for nums2, in which we are going to have the count of all of the numbers for the respective arrays. But actually, instead of just comparing, we could probably just have one single hash map, which is going to count every time a digit, a number is present in the array. And then we could have another loop in which we're going to be decreasing the counts by 1, right? And if we are decreasing it by 1 and the value is greater or equal than 0, we are going to append it to a result, right? So we could have here a res array, which is going to be our output, right? This is the result. This is a hash map that results after iterating through the first array. And for the second array, we're going to be decreasing the numbers, right? So here we have a 2. We're going to decrease 1. So since this is still greater or equal than 0, we are indeed going to append that number. And then we're going to decrease 2 again. And since this is still greater or equal than 0, we are going to append it once again. And well, in this case, we would indeed have the correct output. But let's go ahead and try this same approach with example 2. So we're going to have our hash map for nums1. We're going to have 4, 9, and 5, each once. Rest is going to be empty. And for nums2, we're going to be decreasing 1, right? So here we could decrease 1 to 9. This is going to be 0. And since this is 0, greater or equal than 0, we're going to append 9 here. Then we're going to iterate through 4. We're going to decrease 1. Since this is greater or equal than 0, we're going to append it. Then 9, we're going to decrease 1. Is this greater or equal than 0? It is not, so we're going to forget about it. 8, right, we could probably add it. So we're going to have here like -1. And for 4, we are also going to decrease -1, and we would do nothing in this case. Now, we could use a hash map, or really could be an array of just an array from 0 to 1,000, since this is actually one of our constraints. So this would make it space complexity of O of 1,000, even though it's constant, is a big number. But I believe we can make do with this type of approach. So let's just go ahead and try to code this up. We're going to have the count of our array, so count nums is going to be equal to 0 times 1,000. Well, that was actually wrong. 0 times 1,000 elements, right? Plus 1, since this can actually be 1,000, right? Then we're going to start iterating through nums. So for n in nums, we're going to increase 1. Count nums at n plus equal 1. And then we're simply going to iterate through nums2. Here's actually nums 1. We are also missing our res variable, which is what we're going to return. Let me just put this here. And now we're simply going to be decreasing. So count nums at n minus equal 1. And well, if count nums at n is greater or equal than 0, we're going to res dot append n. And that, I believe, really should be it. Let me just go ahead and see if my algorithm would work with one of these examples. 1, decrease 1 to 9, 9, 8, 4. I believe this could work. There's probably going to be a bug. Hopefully there isn't. Crossing my fingers here. Okay, so 2 test cases accepted. And what happens if we submit this? Okay, so there it is. Of course, our time complexity for this algorithm is very efficient, but space complexity wise, it's a little lackluster. So, but nevertheless, I'm very happy with this result.